Okay, this review is going over moles. First question's asking what is the definition of a mole? And a mole is a counting unit. It's a specific amount of something. Number two, what is Avogadro's number? Avogadro's number is equal to 1 mole. And that number, that counting unit for 1 mole will be 6.02 times 10 to the 23rd. So anytime I'm asking for a mole, that's how much I want in 1 mole. All right, number 3, determine the molar mass for each of the following compounds. So to determine the molar mass, we're going to need to find the mass on the periodic table. Here we have hydrogen with a 2, so that means we have 2 hydrogens. And we're going to multiply it by the mass, which is 1.008. For bromine, we just have 1, so we don't need to multiply it. And the mass for bromine is 79.904. I'm going to plug in all of this into my calculator and add them together. So 2 times 1.008 plus 79.904, bless you, 81.92. And that's grams per mole. For D, I have a calcium that's not in a parenthesis, so I just have 1. But then my NO3 is inside of a parenthesis, and there's a 2 on the outside, so I'm going to have 2 nitrogens. And then I'm going to have to multiply my subscript for oxygen, which is 3 times 2, so that'll give me 6 oxygens. So for calcium, it's just 1. The mass for calcium is 40.078. For nitrogen, I have 2, and nitrogen's 14.007. And for oxygen, again, I have 6, and the mass for oxygen is 15.999. I'm going to add these all up. 40.078 plus 2 times 14.007 plus 6 times 15.999. That's going to be 164.086. And that's grams per mole. Number 4, how many grams are in 7.28 moles of ammonium carbonate, NH42CO3? So this is going to be a moles to gram setup. I'm going to start with my moles, 7.28. Since my moles is in the first box, diagonal at the bottom, I'm going to put 1 mole. That's just my standard. And above that, since I'm looking for grams, I'm going to put my molar mass of NH42CO3. So I'm going to have to solve that. I'll do it over here on the side. For nitrogen, since I have a 2 outside the parentheses, remember the 2 is going to go to the N and the H. So I have 2 nitrogens times the mass for nitrogen. Again, it's 14.007. For my hydrogen, I have 4 in the parentheses and a 2 outside. So together, 4 times 2 is 8. I have 8 hydrogens times 1.008. For carbon, it's just 1. Carbon on the periodic table is 12.011. And then for oxygen, I have 3. And oxygen is 15.999. So I'm going to add those all up. Plus 8 times 1.008 plus 12.011 plus 3 times 15.999. That's going to be 96.086. So I'm just going to simplify that to 96 in my box. 96 grams. When I'm solving these problems, I'm going to multiply the ones across from each other. So 7.28 times 96, that's going to be 698.88. I would sometimes divide by the bottom number, but since the bottom number is 1, I really don't need to divide. So my final answer rounded would be 698.88. Number 5, how many moles of H2O are in 8.93 grams of water? So this time I'm starting with grams and I'm looking for my moles. So this is a grams to mole problem. I'm going to do 8.93 grams H2O. Since I'm starting with grams this time, I want my molar mass of water at the bottom. And above that, I'm just going to put my standard 1 mole. So now I need to find the molar mass of water. H2O, there's 2 hydrogens. So 2 times 1.008. And oxygens, it's just 1, so that's 15.999. I'm going to do 2 times 1.008 plus 15.999. That's about 18.015. To simplify that, I'm just going to put 18 grams in my box. This time I don't need to multiply the top because any number times 1 is the same number. So I'm going to divide by the bottom. I'm going to do 8.93 divided by 18. That's going to be about 0.496, which rounds to 0.50 moles. Let's move on to number 6. How many moles of oxygen gas, O2, are in 8.20 times 10 to the 23 molecules? This time I'm starting with an amount of molecules and I'm trying to look for moles. So I don't need mass at all in this problem. That's 8.20 times 10 to the 23rd. And those are my molecules. Since I'm dealing with a large number, I'm going to use Avogadro's number at the bottom. And that was 6.02 times 10 to the 23rd. And above that, I'm going to put my 1 mole standard number. Again, notice I did not use any mass from the periodic table in this problem. You do not always need mass. I don't need to multiply the top rows because any number times 1 is the same number, but I am going to need to divide. And if I'm working with my large numbers that are in scientific mode, I'm going to need to put parentheses around them. If I don't put parentheses around them, I'm going to get the wrong answer in the calculator. So with your calculator, type parentheses 8.20 times 10 with the caret 23. Close that parentheses, hit divide, start a new one. 6.02 times 10 with the caret 23. Close the parentheses, enter. That's 1.36. And we were looking for moles. Number 7, how many particles are found in 4.72 grams of iron 2 sulfide? This time I'm given grams and I want particles. So this is a two-step equation. I'm going to start with my grams, my given, 47.2 grams of FeS. Below that, since I started with grams, I'm going to want my molar mass. So I'm going to do that down here at the bottom. Iron has a mass of 55.845. And sulfur has a mass of 32.066. I'm going to add those two numbers, 55.845 plus 32.066. That's about 87.911. And to put it in my box, I'm just going to round that to about 88 grams. Above that, I'm going to put my 1 mole. That's my standard number. I'm not done though because I want particles, so I'm going to use Avogadro's number as well in this one. At the bottom, I'm going to put my 1 mole standard, and above that, I'll put Avogadro's number, 6.02 times 10 to the 23rd. Remember to put that large number in a parentheses. Now, since we have more boxes, we are going to have to do the multiplication on the top row, multiply on the bottom, but any number times 1 is the same number. And then we're going to divide the top row by the bottom row. So on the top row, we got 47.2 times 1 times parentheses 6.02 times 10 with a caret 23. Close that parentheses. That's 2.841444 times 10 to the 25. But then I still need to divide by 88. So I'm just going to hit the divide button by 88. And that's going to be my final answer, 3.2289 times 10 to the 23rd. Let's round that to 3.23 times 10 to the 23rd. And that's going to be my particles. Number 8, what is the mass in grams of 2.25 times 10 to the 24th molecules of H2PO4? This time I'm starting with molecules, and this time I'm looking for my mass. So always start with your given, 2.25 times 10 to the 24th. Those are my molecules. Since I have a large number at the top, I'm going to put Avogadro's number at the bottom, 6.02 times 10 to the 23rd. And then I'm going to put my standard 1 mole on top of that. But I'm not done because I want grams. So on my last box, since I have 1 mole at the top, I'm going to put 1 mole at the bottom. And above that, I'm going to put the molar mass of H2PO4. Here I can see I have 2 H's. So I'm going to do 2 times 1.008. I have 1 P, and the mass for phosphorus is 30.974. And for my oxygen, I have 4 oxygens, and my mass for oxygen is 15.999. So plugging all that into the calculator, 2 times 1.008 plus 30.974 plus 4 times 15.999. That's going to give me 96.986. And I'm going to round that to about 97 grams. Now I can solve. Remember to put those large numbers in a parentheses. We're going to multiply the top numbers. You don't really need to multiply by 1 because any number times 1 is the same. But you are going to have to divide by that bottom number when you're done. So let's do parentheses. 2.25 times 10 caret 24, close parentheses, times 1 times 97. That's the top row. Now I'm going to divide by 6.02 times 10 to the 23. I don't need to multiply by 1 because any number times 1 is the same. So we're just going to hit divide, parentheses, 6.02 times 10 caret 23. And that's going to be our final answer, about 362.54 grams. Number 9, how many atoms are in 5 moles of aluminum? I'm given moles, and this time I want atoms. This is a simple one step. Here's a hint. Anytime you see the word mole, it's always going to be a one step. So let's start with 5 moles. I'm going to put my standard 1 mole at the bottom, and above that, now I want atoms, so I'm going to use Avogadro's number. 6.02 times 10 to the 23. Remember to put it in parentheses, and you're going to multiply the top row. You don't need to divide by 1. Any number divided by 1 is the same number. So we're going to do 5 times parentheses 6.02 times 10 caret 23. Close that out. That's 3.01 times 10 to the 24th. And those are our atoms. Let's go ahead and go to the back page. What is the percent composition of oxygen in CO2? This is going to be 2 steps. First, we need to figure out the mass of just my oxygen. There's 2 of them. And the mass for one is 15.999. So that's 31.998. So that's my first step. My second step is to find the total mass for CO2. So I have 1 carbon, and the mass for carbon is 12.011. And then for my oxygens, again, I have 2. So that's 2 times 15.999. So 12.011 plus 2 times 15.999. That's 44.009. Now I want the percent composition of oxygen and carbon, so I'm going to do my mass of oxygen divided by my total mass of CO2, 44.009, times 100, and that's going to give me my percentage. 31.998 divided by 44.009 times 100. That's about 72.7078. So let's round that to 72.71%. Number 11, what's the percent composition of zinc in Zn2CO3? So again, first step, let's find the mass of zinc. For zinc, there's 2 of them. So I'm going to do 2 times the mass of zinc, which is 65.38. That's 130.76. And then I gotta find the total mass for my whole compound. So zinc again has 2 times 65.38. For carbon, I have just 1, 12.011. And for oxygen, I have 3 times 15.999. I'm going to add that all up. Plus 12.011 plus 3 times 15.999. That's going to be 190.768. Now I'm going to do the mass of zinc divided by my total mass. Times 100. So 130.76 divided by 190.768 times 100. That's 68.5439. So let's round that to 68.54%. Number 12, what is the percent composition of oxygen in Ag2SO3? Again, I want oxygen, so I'm going to just focus on that. For oxygen, I have 3 of them, and the mass for oxygen is 15.999. That's 47.997. And then I need to find the mass of my whole compound. For Ag, that's silver, there's 2 of them, and the mass for silver is 107.868. For sulfur, I have just 1, and that's 32.066. And for oxygen, I have 3, and that's 15.999. Add that all together. That's 295.799. All right, next I'm going to do oxygen divided by my total. Times 100. So 47.997 divided by 295.799 times 100. That's 16.226. So let's round that to 16.23. Moving on, 13. What is the difference between the empirical and molecular formula? So molecular formula is the true formula of a compound. And an empirical formula is a simplified version of the compound. Or a reduced. A reduced formula of a compound. Determine the empirical formula for each of the following compounds. Circle the compounds that have identical molecular and empirical formulas. So for H2O, H has a 2 subscript, but O doesn't have a subscript, so we can assume it's 1. These numbers cannot be simplified anymore, so it's going to have the same empirical formula as molecular. So I'm going to circle this one because they're the same. For B, carbon has 2 and hydrogen has 8. Both of these can be divided by 2. So that means carbon will not have a number because remember, chemists don't like writing ones. And then hydrogen, 8 divided by 2 is 4. So hydrogen will have a 4. Going to C, we have P3O6. Both of these numbers can be divided by 3. So P would have a 1, but we don't write 1s in chemistry. And O6 divided by 3 is 2, so it's O2. And for D, NH3, we can't simplify that anymore. N doesn't have a number, so it would be a 1. We can't simplify that, so it would stay NH3. And I'm going to circle that because it has the same molecular and empirical formula. All right, that is it for going over the moles review.